So this completes working with deadlock detection, prevention, and recovery, right? So I hope that it's quite simple, right? So you have a set of transactions T0 to Tn, where T0 transaction T0 is waiting for the data item that is being held by transaction T1, and T1 is waiting for the data item that is being held by transaction T2, and transaction Tn minus 1 is waiting for the data item that is being held by transaction Tn, and transaction Tn is waiting for the data item that is being held by transaction T0. Then we say that the transactions are in a deadlock state, right? So we need to look for algorithms for preventing the deadlock. So one method to prevent the deadlock is that whenever a transaction starts its execution, it acquires all the data items at the beginning of its execution. However, the disadvantage in this approach is that it's very difficult to predict the data items that is being needed in advance before the beginning of the transaction. And again, data item utilization may be very low, since in this case many data items may be locked but may not be used for a very long time. So what we do is that we allow deadlock to happen. We detect deadlock using a wait for graph, right? So wait for graph is a simple graph with the vertices and edges. G is equal to V comma E, where V corresponds to transactions and E represents the edges between the transactions, right? So if a transaction is waiting for an data item that is being held by transaction Tj, then there exists an edge between the transaction Ta and Tj, right? So we'll be constructing a wait for graph for the transactions, and if there is a cycle in the wait for graph, we say that the transactions are in a deadlock state and none of the transactions can proceed to its completion. However, if there is no cycle among the transactions in the wait for graph, we say that all the transactions can proceed to its completion, right? So by means of wait for graph, you'll be able to detect whether the transactions are in a deadlock state or they can proceed without any conflicts. And how to recover from deadlock is that you need to select a victim. A victim is chosen based on the cost factor. Like you are going to identify a transaction that can be rolled back, which with some minimum cost. So it is computed by based on the number of resources already consumed by a particular transaction, how many resources, how many data items it needs for further completion, how many transactions will be involved in the rollback, and so on. You will be selecting a victim, right? So once you have identified the transaction to be rolled back based on the cost factor, either you are going to go for a full rollback or total rollback, or you are going to go for partial rollback. So if you are going to go for partial rollback, you are going to maintain some additional information about the state of all the running transactions. And final thing that you need to know in deadlock recovery is that whenever you are going to roll back a transaction based on cost factor, it is likely that the same transaction is likely to be rolled back for the same transaction is picked up as a victim repeatedly. So as a result, that the same transaction, the transaction will be never able to complete its designated task, and it's known as starvation. So the final thing is that you are going to put a criteria that a transaction can be rolled back only for a finite number of times, right? So this way you'll be able to detect deadlock and prevent deadlock. You will be able to recover from deadlock.